So this is Lecture 3, Food Contamination and Control. And the aim of this unit is to provide an understanding of microbiological, chemical, allergenic and physical contamination of food and to outline the importance of controlling contamination to prevent food poisoning. And learning outcomes, by the end of this module, you will be able to identify the sources of microbiological contamination, name the causes of contamination, define sources, vehicles and routes of contamination, and lastly understand the difference between microbiological, physical, chemical and allergenic hazards. So again, let's have a look at some definitions. Contamination is the presence or introduction of hazard. That could be microbiological, such as pathogens or spoilage bacteria, and these are present in raw materials and can be introduced between delivery and service. We've got physical contamination of foreign bodies, things that you can see in the food usually, things that might be pretty innocuous, like bits of string, bits of polythene, bits of wood, etc. But again, it could be food safety hazards such as sharp screws or pieces of glass. These can be present in the raw materials and they can be introduced between delivery and service. Chemical, these can be present in raw materials, again introduced between delivery and service. One such chemical which could have adverse chronic effects are excess additives. And lastly, allergenic. These are again present in raw materials and these can be introduced between delivery and service. So let's have a look at the sources, vehicles and routes of contamination. Sources could be from the food handler. We've got a graphic there showing the food handler. We've got raw poultry, chopping boards, we've got insects, dogs, we've got rodents, we've got dirty muddy boots, you've got a refuse container, you've got packaging. So all these are sources of contamination. The vehicles, or the more technical words called fomites, F-O-M-I-T-E-S, these can be the apron of the food handler, can be the handler's hands, and again, hands are the biggest source of cross-contamination in the kitchen. So obviously you need to make sure that the food handler's hands are washed regularly. So we've got utensils, you've got food containers, cloths, etc. And lastly, the high-risk foods, which if the bacteria get onto, they will start growing happily under ideal conditions. And if the food is eaten then by a customer, that will cause food poisoning. So cross-contamination. We've got different ways of cross-contamination. One is by direct contact, where raw meat comes into contact with cooked, ready-to-eat food, actually touching. We've got indirect contact, where again you've got the raw meat coming into contact with a fomite, and then that fomite coming into contact with the high-risk food. Drip is another source of cross-contamination, where raw meat juices could drip onto high-risk food if, for example, you hold those foods in a refrigerator where the raw meat is above the high-risk food. So obviously in a refrigerator, high-risk food must be above raw food. So control of bacterial contamination. We can remove the sources, in other words, purchase food from reputable suppliers. This is really part of the HACCP system of the Food Safety Management System. You can check delivery vehicles, inspect food on arrival, immediate storage, integrated pest management, set a system up for that, which we'll be looking at in some detail later on. Good personal hygiene and exclusion policy for people that have been sick or been abroad to various countries where food poisoning is rife, for example. And a visitors policy. In other words, visitors do not go into the working area in the kitchen unless they're attired in a food handler's uniform or disposable aprons, and that they're aware of the food hygiene policies. Again, control of bacterial contamination. We can break roots by effective instruction, supervision and training. Good design of premises and equipment. Good hygiene practices and high personal hygiene. Protect food. Minimize handling of food. Segregate high risk and raw food. A good way of doing this is to have a colour coding system, especially with colour coded preparation boards and knives. Effective cooling and thawing systems. Segregate fit from unfit food. Cleaning schedules and systematic cleaning. And a satisfactory waste management system. So how can we prevent multiplication? We can store food out of the temperature danger zone. Remember, the temperature danger zone is between 5 and 63 degrees C. Fermentation of food products. This reduces the pH to make it more acidic. Therefore, bacteria won't grow. The use of preservatives. Again, natural preservatives are the preferred option. Although we still use other preservatives such as nitrates, nitrites, potassium sorbate, sodium benzoate. Again, this will prevent the multiplication of bacteria. Another one, keep foods dry, or keep dry foods dry. By denying bacteria moisture, they won't grow. Further control, we can destroy bacteria through thorough cooking. Now, I've already gone through the cooking temperatures. From a food safety point of view, the Food Standards Agency and other agencies stipulate that we should cook food thoroughly to 75 degrees C, although from a food quality point of view, anywhere between 60 and 63 is fine. It's safe and you get a far better quality of product. But at the end of the day, this is a food safety course, so any questions that come up, obviously you need to take the stance of food safety rather than food quality. Processing, thoroughly processing the food, disinfection, preservation. Controls include removing the sources, preventing contamination of food by breaking the root, preventing multiplication of bacteria, destroying bacteria, and destroying unfit, suspect or contaminated food. Contamination in retail premises could come from customers. For example, there's shopping bags, bringing pets into a retail premises. Again, there's you normally see signs where dogs are not allowed into catering premises unless they are guide dogs. So obviously guide dogs have far better hygiene values than ordinary dogs. The other one is staff. Obviously staff with poor hygiene practices can cause infection and contamination. Blowing into bags, for example. Licking fingers. Contamination from customers and staff. Coughing. Sneezing. Spitting. Handling food. Smoking. Cuts and sores. Clothing and hair. So physical hazards can come in raw materials. For example, we've got pebbles, snails, stalks, leaves, wood, glass, insects and rodents. These can cause broken teeth, cuts in mouth, choking and psychological damage. The control factor here is to use approved suppliers. Physical hazards again can come from packaging materials such as staples, cardboard, string, fibres, cloth, rubber, plastic, wood and polythene. The control factor here is to take care deboxing, so that hopefully or possibly should be in a separate area to where the food is prepared. The use of metal detectors and the use of magnets. Structured equipment notices and cleaning. Now things like wood, nuts and bolts, plaster, paint flakes, grease and oil, glass drawing pins, cloths and bristles. Control factor U would be care with maintenance and cleaning activities. Also good design of food premises. Use non-corroding materials. Avoid temporary repairs. Have a glass policy. Have a wood policy as well. And the use and storage of cleaning chemicals. Again, away from the food preparation area and only used when food is not being prepared. Personnel, visitors and contractors. With these you could get jewellery, fingernails, buttons, combs, pen tops, sweet paper, cigarette ends and hair. Bits of tissue, and there's other things as well. Control factor, good personal hygiene. Pests and pesticides, rodents, drop-ins, hair, bait, insects, eggs, larvae and molts. The control factor is to have a good integrated pest management system, again which we'll cover in a later lecture. General detection methods include sieves and filters, illuminated inspection belts, personal spotters on inspection belts, metal detectors, magnets, X-ray equipment, optical systems, colour sorters, and air and liquid separators. Their effectiveness really depends on specification, maintenance, settings, age and use, testing frequency and parameters, staff training and supervision. And just to remind you again, there's more information in the notes that you can download from the top page of this site. It will go into more detail, and it's handy really to have and to read through before you actually take the exam. Chemical contamination of food can come from pesticides. These could be pesticides used on a farm, in the food premises themselves, industrial chemicals from environmental contamination, for example, freezer breakdown, you could get ammonia from that, mercury, usually from fish, fertilizers, where they use a lot of nitrates, and veterinary drugs such as antibiotics. Chemical contamination of food can also come from cleaning activities, such as cleaning in place, storage in food containers, spraying near food, storage with food. Packaging is another thing where you can get chemical contamination, where if you keep products in inappropriate packaging materials. I'll give an example of plastics. Certain plastics, if they're not classed as food safe, could well contain certain industrial dyes and chemicals, certain poisons like arsenic and strychnine in when they actually make them. And these chemicals can leach into the food products. So this is why it's important to use food safety packaging. Allergenic hazards are an increasing problem. The immune system can react within minutes. Anaphylactic shock is, or anaphylaxis is a life-threatening situation where a person's throat can start to swell, can block the throat, and so that person can't breathe. They can go into respiratory failure and can actually die within several minutes. That's a serious end, if you like, of an allergic reaction to food. Other allergic reactions to foods can just be a bit of a rash, perhaps a bit of numbing or itching around the lips, a bit of swelling within the lips as well. But the anaphylactic shock can happen where somebody does have a severe allergic reaction to food. Allergen control systems include avoid contamination, segregation, separate utensils and cloths, etc., clear labelling, effective cleaning, hand washing before preparation, staff training, such as good communication, tell them about the symptoms and what response they should take if they see that a customer is coming down with an allergic reaction to food, or in fact is coming down with anaphylaxis. And further on in the lectures, we will be going through the 14 different allergens that have been recognised, and we now have to make sure we put those allergens on displays, and make sure we communicate to the customer that if they do suffer or are allergic to any of the 14 allergens, they must let the staff know so that steps can be taken. So the key points of the lecture: we looked at sources, and they include people, raw foods and pests. Vehicles include hands, equipment and cloths. Routes taken by contaminants to reach high-risk foods was covered. We can disrupt the route by good design, practice, disinfection and cleaning. Physical, foreign body, can come from packaging, equipment, structure, people, pests and customers. And chemical contamination can occur during growth, processing, preparation, transport or sale.